Alright, in this video we're going to talk about understanding randomness. So, what does it mean to be random? It's an outcome is random if we know the possible values it could have, but not which particular value it will take. So we know what the possibilities are, but we don't know what one will come up. Individual outcomes are uncertain, but with many trials run, a pattern will start to show up. Okay, so some examples of things that are random: rolling a dice, flipping a coin, drawing a card from a deck, the gender of a child. Okay, usually you're going to have a boy or a girl, but you don't know which one. Winning lotto numbers. Alright, how do we get random numbers? It's surprisingly difficult to generate completely random values. Okay, so even most computer programs and softwares have some sort of algorithm to come up with these random values. So it's very difficult to be completely random. Alright, so we could have a table of random digits. Okay, so there's one that you can look up in your book, or it's usually given, like a small section of the random digits, it's given on the problem or assessment. You're going to pick a line to start at, and then you're going to read across from left to right. It can be a single digit, 2 digits, 3 digits at a time, whatever, depending on the problem that you're working with. You can get random numbers from your calculator, so it's math. Then you go over to probability, and then random integer, and you put in your lower number, the smallest number you're looking for, the largest number you're looking for, and then you can put the lower value, comma, the larger value, comma, however many numbers you want at one time. So if you wanted to get 5 numbers at a time, you could do it that way. Flipping a coin, assigning a number or range of numbers to heads and tails. Same with rolling a dice, assigning certain numbers with each side of the dice. Alright, and then a simulation is what we're going to do when we're talking about randomness. A simulation is modeling a real-world situation by using random digit outcomes. So to set it up, we're going to assign numbers to each outcome based on the outcome's probability. We're going to use a random number generator, either a table, flipping a coin, the calculator, whatever, to generate these assigned numbers. These will simulate an event happening. Okay, so trial, the parts of this simulation. A trial is each time we simulate an event, and the response variable is the outcome of the trial. And then stopping, 2 ways to stop a simulation is you do a certain number of trials, so you run that many trials, or you achieved a certain value until, so you're working on it until you get to something, then you move to the next one. Alright, what you need to write for each problem. So you need to first list the outcomes and their probabilities of happening. 2, you need to identify random number generator. So did you use a table of random digits? Did you use a calculator to get your random values? Did you flip a coin? And assign numbers to each outcome based on probabilities. You need to tell me what one trial is equal to, how many trials you're going to perform, and then what the response variable is. Okay, so let's look at an example. So in this example, they gave us a table of random digits. It says a baseball player gets a hit in 30% of his at-bats. Simulate him coming to bat 12 times. So I already know that his probability so far is 30% hits. So I'm going to run a simulation. So I'm going to use the table of random digits, and I'm going to say hits are going to be numbers 1, 2, and 3. If it's not a hit, I'm going to use the numbers 4 through 9 and 0. Okay. I could do it differently. I could use different numbers instead. I could use the numbers 0 through 2 as hits, and then 3 through 9 as not hits. Or I could use the numbers 0, 1 through 30 for hits, and 31 through 99 and 0, 0. Okay, so those are the 3 different ways that I could use this table of random digits to assign the numbers. Okay, normally you wouldn't pick all 3, you just pick the one that you're going to choose. 1 trial is equal to 1 at-bat. We're going to perform 12 trials, and my response variable is equal to the number of hits. So I'm going to use this method. So numbers 1, 2, and 3 are hits. 4, 5, 6, 7, 8, 9, and 0 are not hits. So I'm going to do 12 trials. So I'm going to look at the first 12 numbers. So the first number is a 3. So that's a hit. The next number is a 9. That's not a hit. The next number is 6. That's not a hit. 3. That's a hit. 4. Not a hit. 6. Not a hit. 2. That's a hit. 3. That's a hit. 4. Not a hit. 9. Not a hit. 7. Not a hit. And 4. Not a hit. So now I've run the simulation. And then you could be asked various questions like what's the probability of a hit? Well, 4 out of 12. The probability of not a hit would be 8 out of 12. And so forth. Alright, example 2. Picking a card and looking at the suit. Simulate 10 picks. Okay, so I have hearts, diamonds, spades, and clubs. And if you don't know a lot about cards, you need to kind of have some stuff memorized about cards in case you're asked questions about them. So, for cards, we have 4 suits, hearts, diamonds, spades, and clubs, and they're equally likely, so that 25% are hearts, 25% diamonds, 25% spades, 25% clubs. Alright, and then I'm going to use a table of random digits, and I'm going to let hearts be, this is one way I could do it. I could have hearts be the number 1, diamonds be the number 2, spades be the number 3, clubs be the number 4. So 1, 2, 3, and 4 out of 4 digits, each one has one number. So it's 25%, and I would ignore all numbers 5 through 0. Or I could use hearts, the numbers 1 and 2, diamonds 3 and 4, spades 5 and 6, clubs 7 and 8, and ignore just 9 and 0. That would be a little bit more manageable since I'm only ignoring 2 different digits. Or I could use the numbers 1 through 25, 26 through 50, 51 through 75, 76 through 00. Alright, that's not too bad, except for then you have to block off every 2 digits. You have to look at every 2 digits, which isn't too bad. Alright, 1 trial is equal to 1 pick. The response variable is the suit of the card, and I'm going to perform 10 trials. Alright, so I'm going to look at this middle one. I'm going to ignore all numbers 9 and 0. So I'm going to get rid of all the 9s and 0s. So the first one is a 6, which is a spade. The second number is a 4, which is a diamond. The third is a 6, which is a spade. Next one's a heart. Next one's a club. Next one's a club. I'm skipping that one. Next one's a heart. Heart again. Spade. Skip the 9. Heart. So I did 10 trials, and then I could answer some questions based on the simulation that I ran. Alright, example 3. Back to the baseball player who got a hit 30% of the time. Assume he gets, on average, 3 at-bats per game. Simulate 15 games, recording the number of hits per game. What is the average number of hits per game? So hits is 30%, not a hit is 70%. I'm going to use the table of random digits. Hits will be the numbers 1 through 3. Not a hit will be the numbers 4 through 0, so 4 through 9, and then including 0. 1 trial is equal to 3 at-bats. Okay. The response variable is the number of hits in 3 at-bats. Okay, so the number of hits in 1 game, because we're assuming he gets 3 at-bats per game. And then I'm going to perform 15 trials. So I have to look at the numbers every third number, or every group the numbers, look at 3 numbers at a time. So I'm going to look at the first 3 numbers, 8, 0, and 5. So I'm going to group them into 3 number chunks. Okay, number of hits. So I could get 0 hits in a game, 1 hit in a game, 2 hits in a game, or 3 hits in a game. So the first one, 8, 0, and 5, that's 0 hits. The next one, he got 1 hit in that game. The next game, he got 1 hit. The next game, he got 2 hits. The next game, he got 0 hits. Then 1 hit. Then 1 hit. Then 0. Then 1. Then 1 again. Then 1 again. 1 again. 0. 1 again. 0. So that was 15 trials. So you have to make sure, you got to be kind of careful that you have grouped it into 3, because I'm looking at 3 at-bats per game. So each number is an at-bat, and each section of 3 is 1 game. So this is the number of hits he got in that game. So then I could take these up, and I have 9 ones, I have 1 2, and I have 5 zeros. So if I add those all up, and I divide by 15, I get an average, remember average is x bar, mean is x bar, of 0.733 hits per game. Alright. A stat class consists of 46% males. A teacher needs to pick a group of 4 students. What is the average number of males in the sample? Simulate this 10 times to make your decision. Okay, so males is 46%, females is 54% then. I'm going to use a table of random digits. I'm going to let males be the numbers 1 through 46, females be the numbers 47 through 00. Okay, and you don't want to use 47 through 100 and not use 00, because then you have some 2-digit numbers and 3-digit numbers. We can't have that. Oops. All right, 1 trial is equal to 4 students. My response variable is the number of males in that group of 4 students. And I'm going to perform 10 trials. So I'm looking at 4 students at a time, but I'm looking at 2-digit numbers. So I need to look at 2-digit numbers and then look at 4 sets of 2-digit numbers. So my first set of 2-digit numbers, and then how many males were in that. So I had 1 male in the first set of 4 students. In the second set, I have 3 males. The next set, and I'm breaking it into 2 digits because I'm using 2-digit numbers. So males is 0, 1 through 46. So any number less than 46 and not 0 is a male. And then numbers 47 and above are female. So I'm looking at 4 sets of 2. So the next one had 2. The next one had 3. Another set had 1. And the next set had 3. Had 1. So I'm going to keep going on. Okay, and I'm going to keep doing this until I've done 10 trials. So I have 10 trials there. And then I could average them up. So I had 4 1s, 3 2s, 3 3s. Add those all up, divide by 10. I get an average of 1.9 males per group. Alright, example 5. Picking a card and looking at the suit. We want to pick cards until we get a heart. How many cards will we need to pick? So I'm going to do 10 trials. Hearts is 25%. Anything that is not a heart would be 75% of the cards. I'm going to use a table of random digits. Hearts will be the numbers 1 and 2. Not a hearts will be the numbers 3 through 8. That means I'm going to ignore the numbers 9 and 0. If you want to use the numbers 1 through 25 and then 26 through 00, you could do that. Okay, but then you have to break everything into 2 digits at a time. And it's kind of simpler to just look at 1 digits. But if that works better for you, you can do that way. Just have to make sure you identify what you're counting. So I'm going to go ahead and cross out all the 9s and 0s. Alright. One trial is going to equal, or one trial is until I get a heart. And then my response variable is the number of cards that it took until I got a heart. And I'm going to perform 10 trials. So I'm going to look, starting at the very beginning, I'm going to look and see how many cards I need to pull until I get a heart. So I'm looking for either the number 1 or 2 to come up. So it only took 2 cards to get a 1 or a 2. The next one, it only took 1 card. The next one, it took 4. The next one, and you're not counting anywhere where you had a 0 or 9. You're just completely ignoring those. It took me 16 cards until I got a heart. Okay, and then 4 for the next one, 8, 4, 8. Okay, and then I have to kind of go on to the next line because I have to do 10 trials. And right now I only have 8 trials, so I need to do 2 more. So I had to cross out all the other 9s and 0s in the next row. And then I'm looking until I get a 2 or a 1. So it took me 10 for the next one and 7 for the last one. So if I add up how many cards it took divided by 10, then the average. So how many cards will you need to pick on average to get a heart? 6.4. So on average, 6.4 cards are pulled before you get a heart.